In this video, we're going to take utility maximization theory one more step. And what we're going to do is, given a utility function and prices and an income, we're going to analyze the impact of a price change on consumers. And what we're going to do is find income and substitution effects. Now, what we're doing here is based on a Russian economist named Slutsky, and Slutsky came up with this equation we call the Slutsky equation. And the Slutsky equation, instead of writing it in math terms, I'm just going to write it in terms of English today. What the Slutsky equation does is explain the law of demand in a little bit more detail. And it says, look, the law of demand says when the price goes up, quantity goes down. When the price goes down, quantity goes up. Why? Well, if you ask people, people will tell you there are two reasons why I buy less when the price goes up. Reason number one, so what Slutsky said is, look, there's this total impact, there's a total effect of a price change. And he says we can break that into two parts. Why do you buy less when the price goes up? Well, reason number one, part number one, is that when the price of something goes up, you buy less because it's more expensive. I mean, believe it or not, it's that simple. To be a little bit more scientific, you buy less because something is now relatively more expensive than substitutes. And so when the price goes up, you buy less because of the relative price change. So the relative price changed, and that's going to cause you to buy substitutes. So Slutsky called this the substitution effect. That's part of the total effect. The second reason why people will buy less of a product when the price goes up is because it makes you feel poorer. And when the price of gas or electricity or your rent goes up, you're going to try to buy less of it, or with rent you'll get a smaller apartment, buying less of an apartment, because it makes you feel poorer when the price of something goes up. And Slutsky said, let's call that the income effect. Higher prices make us feel poorer, and a change in relative prices will make us, between two goods, will make us substitute between them. And so what we're going to go through today is how do we decompose the total effect of a price change into these two parts. So let me set up a problem here, and we'll go through and we'll decompose the total effect into these two parts. Okay, here's our problem. Suppose we have a utility function, utility equals x to the 0.5 times y to the 0.5, or square root of x times the square root of y. The price of x is $2, the price of y is $1, and our budget is $4. What we're going to change here is we're going to analyze the impact of changing the price from $2 to $1. So let me say what's going to happen here if that price instead of $2 becomes now $1. So Slutsky told us how we can decompose these impacts. And he said, look, here's what you do. Let's call it step A. Part A of the problem is to do just like what we've done in previous videos and find the original solution. What is our best choice between goods x on the x-axis and y on the y-axis here with the original prices of $2 and $1? So what's the original solution? B, find the final solution after the prices have changed. So find the final solution. And the difference between A and B is going to be what we call the total effect. So that'll be our total change from the actual, what do we actually do when the price is $2 to what do we actually do when the price is $1. In order to decompose this effect into how much of it is caused by the relative price change and how much of it is because we feel richer in this case, because this is a decrease in price, we need to come up with a third solution, C, which we'll call the hypothetical solution. Hypothetical. Now, let me run through basically what Slutsky's hypothetical solution says. But first, let's find these original solutions. Now, not going to spend a lot of time going through this because I have other videos talking about how to maximize utility. You pause the video, I'll do the same, and I'll solve these first two, A and B, for the original and the final solution, and I'll graph them over here as well. And then we'll come back and we'll talk about the hypothetical solution. Okay, so solving these, you set the marginal rate of substitution, which is y over x for this utility function, equal to the ratio of the price of x over the price of y. And then you look at the also the budget constraint here. Oops, sorry about this. I have a new computer and it's doing weird things to me. And then, so that gives us 1x and 2y's as our best solution here, and a utility of 1.41. Somehow when I point at the answers, it's highlighting them. The final solution after the price change, we have a ratio of prices of 1 to 1, and then our budget constraint is x plus y equals 4 because the price of the goods are both 1. And so in that case, we'd buy 2x's, 2y's, and have a utility of 2. So let me draw these solutions, the original and the final, on this graph here. And first, let me just draw the points. How much x and how much y do we want to buy in each of these situations? So in the original, we're going to buy 1x and 2y's, which is right about here. And in the final, so let's see, we'll make that pink, and I'll highlight that a little bit. In the final solution, let me make that blue here. And that's 2x's and 2y's. That's what we'll buy after the price goes down. Now we need to figure out this hypothetical solution. Now let me draw the budget lines here real quickly for the original and the final solution before we talk about the hypothetical, so you can see what Slutsky was trying to say that we should do. For the original solution, what we're trying to do is find the highest point on an indifference curve that is on a budget line. Now our budget line in the original situation is 2x plus y equals 4, which means we can buy either 4 y's or 2 x's or anything between. So let me draw this line between those 2 points right there as best I can. Okay. And so given that budget line, that little pink point is the point that gives us the highest utility, and that's 1.41 utils for the original solution. After the price goes down and the price of y is 1, we can still afford 4 y's, but we can now also afford 4 x's down here. So we need to connect those 2 points for our new budget line after the price change. All right, so, whoops, that line didn't draw. Just a second. All right, there we go. And so on this new budget line, the blue point is the combination of goods that gives us the highest utility from solving that, and our utility is going to be 2 utils there. Now let's look and see in what sense we can already start to see Slutsky's argument here. There's a substitution effect, which simply is saying that the slope of the budget line used to be very steep, which tells us that when we go to the store, we have to exchange 2 y's for every x we buy because x's are twice as expensive. And so the substitution effect we can sort of partly see by the fact that this budget line is shallower, which means we're going to be kind of inclined towards buying more x because it's now relatively cheaper compared to y than it was before. We can also kind of see how it's like we have a higher income, because what happens when we get a bigger income is we have more consumption possibilities. Look at all of these consumption possibilities out here that we did not have before this price decreased, right? And so in a sense, having all these consumption possibilities that we didn't have before is like having more income. So those are the two different parts that Slutsky was talking about. Now, how does Slutsky actually tell us to do it? To find the hypothetical solution, we're going to take different components of the original and the final solution and come up with something in between. And let me tell you about what that in between solution looks like. We want to take, let me first start with what we normally do. Our two equations when we do a normal utility maximization are these two. The marginal rate of substitution equals the ratio of the prices. That's equation number one normally. That tells us that the slope of the indifference curve is equal to the slope of the budget line. And the second equation we use, we have two equations and two unknowns, is that we want to spend all of our money, the budget line. For Slutsky's hypothetical solution here, we still need two equations to solve two unknowns. But Slutsky said we want to find a point where we have the original utility, level, and in this case that would be utility equals 1.41, that utility level right there. But we want to see what would happen if we were at the original utility level but the new prices. So the new prices but the original utility level. So in particular, what are those two equations going to look like? Well, the original utility is going to be represented by this equation, that the utility function, let me just write the utility function in this case, x to the 0.5 times y to the 0.5. Whatever your utility function is, we want that to be equal to 1.41. The original utility. Now what that's telling us is we want to be on this original indifference curve for the pink point. Now it's not going to be quite this blue one here, but it's going to be an indifference curve kind of like this orange thing that I'm drawing right here. A slightly lower indifference curve there. We want to stay on that orange indifference curve. Let me draw it slightly better here because it shouldn't cut through that original budget line there. Okay, so now we have this. This is the indifference curve for 1.41. I'm drawing it freehand, but it's going to look very much like the other indifference curve that's very close to it over here. So Slutsky said, let's imagine what would happen if we kept the utility the same as before the price went down or up, but we want to look at the new prices. We want to look at the slope of the new budget line, and what that's going to do is that's going to reflect the new opportunity cost, the new ratio of prices. And here's how Slutsky would say to do that. Just take this marginal rate of substitution equals the ratio of the new prices function here. So use this same equation from the final solution, y over x equals 1, marginal rate of substitution equals the ratio of the new prices, 1 over 1 equals 1. But we use the utility from the original solution. Utility equals 1.41, but so that we can solve these two equations, we actually need that utility function, x to the 0.5 times y to the 0.5. Now, how are we going to solve these two equations for two unknowns? What we want to do is figure out how much x and how much y we would want. Before we actually do this, I think you can see how we can do that. Let me draw graphically what we're actually going to be doing here on our graph. What we want to do is pick up this indifference curve that has the slope of 1, right? This budget line, this new budget line with a slope of 1. And what we're going to do is see if we drag the budget line with a slope of 1 backwards until it just touches this same orange indifference curve. So the utility level will be 1.41, but the ratio of the prices is going to be 1 over 1. Then we're going to be on a budget line, kind of like this. Right? So what we want to know is how much X and how much Y would you buy in that situation? Now, why does this decompose this into income and substitution effects? Here's why. The move from point A, the pink point here, to point B is the substitution effect, because the only thing that's changing is the ratio of the prices is changing from 2 over 1 to 1 over 1 for the red budget line, but we're not getting happier. It's not like we're getting more income, and more income makes us happier, right? So the movement from A to B is the substitution effect. Sorry, I shouldn't call that B. We're calling that point C over here. So let me get rid of that. So the move from point A to point B, I said it again, to point, sorry, this computer is doing weird things to me again. The move from A to, I'll just have to write over top of that, to C there, that from the original to this hypothetical solution, which we haven't really come up with yet. I was just showing you graphically how that works. A to C is going to be the substitution effect. Now look at these two budget lines, the red one and the black one. Between the red and the black budget line, the ratio of the prices is not changing. So there's no reason to substitute between goods. It's the only difference between the red and the black budget line there is it's like an income change. It's like we have more money, which causes a parallel upward shift in the budget line. So moving from C to point B tells us how much of this change is due to just like being an increase in income here. So we already see that the overall total effect of this price change is we're going from buying 1x to 2x's. And what we're trying to do here is decompose to figure out, okay, between A and C, that amount's going to be the substitution effect, and the remainder, so between A and C, and then between C and B, that is going to tell us how much of this increase in the purchase of good X is due to the income effect. So again, what Slutsky says is keep your utility the same, but change the ratio of the prices and try to figure out what solution that gives you. What are we going to do? Well, what I would do here is solve this equation for y equals x, and then plug that into that equation right there. So x to the 0.5 times y to the 0.5, plug in for that y, plug in x, and we're going to get, this is going to be a very simple one, x to the 0.5 times x to the 0.5 equals 1.41. In other words, x equals 1.41. So this point C is at x equals 1.41. And how many y's will this person buy? Well, due to this marginal rate of substitution equals the ratio of prices equation, we know y equals x, so y is also going to equal 1.41. And so that is where that point C is going to occur here, is at y equals 1.41 and x equals 1.41. What is the point of the whole story here? Again, Slutsky noticed that when prices change, people buy more or less of that good for two reasons. One, because the relative cost has changed between the two goods, the relative price, and because you feel either richer or poorer due to an income change, due to a price change. He calls that part the income effect. We look at the total effect. What really happens when the price changes? That's the total effect. Well, that's from point A to point B. How much X did we buy? 1. How much do we buy now? 2. That's the total effect. So all we want to do is break down that change from buying 1x to 2x into those two distinct reasons why. Part of it from buying 1x to 1.41x, that 0.41 change we would call the substitution effect, because that change is brought about by just keeping you as happy as you were before, but tilting your budget line right there from the black to the red, just changing the prices but not making you happier like you would with an income change, or less happy if the price went the opposite direction. Then from C to B, all we're doing here is moving your budget line parallel from the red to the black, keeping the prices the same, so there can't be a substitution effect there. That's just the income effect from point C to point B. So in here what we would say is the substitution effect, we're increasing our purchases of X by 1. We're breaking that into two parts, from 1 to 1.41. That part is the substitution effect. The other 0.59 we would say is due to us feeling like we're richer, the income effect. So one last thing that I like to do in this kind of problem is to calculate how much income would we need to get us between these two lines. This income effect, if we're talking about, well, this is because you feel richer, how much richer? We can answer that question. How much income would it take to get from the red budget line to the black budget line? Well, we know with the black budget line, with the new prices, price of X equals 1 and the price of Y equals 1, that this budget line right here is with a budget of $4. Now, at this red budget line down here, how much income would it take to buy that? Well, we're just asking here, how much income would it take to buy 1.41 X's and 1.41 Y's? Well, we can plug that into our budget line equation. The price of X times X plus the price of Y times Y equals the budget. Well, since the price of X is 1 and the price of Y is 1 on this red budget line and this black budget line, that's easy to calculate. It's just 1 times 1.41 times 1 times 1.41 is $2.82 would be our budget. And in order to move us from the red budget line to the black, we'd increase our income to $4. This is a way of answering the question, you know, this price of X going from 2 to 1 made us feel richer. How much richer? Well, it made us feel like our income went from $2.82 to $4. It makes us feel about $1.18 richer. So I know this has a lot of steps to it, and there are a lot of parts to focus on at once. So later on I'll do another video where we look at instead of a price going down, we look at a price going up. But hopefully this will get you started in thinking about income and substitution effects and how to calculate them, and more importantly, what it means. But it does take seeing this and working with it quite a few times before you're going to think that this is absolutely normal.